In Alberto Reyes' 15-year university student life, he graduated the University of Alberta.
So I have a PhD in Earth and Atmospheric Sciences, and I did a master's degree at Simon Fraser studying glaciers and glacier change over the last 10,000 years. And I have an undergraduate degree in physical geography.
It qualifies Professor Reyes as a geochemist and geomorphologist as he begins teaching at the U of A this year. But he remains an active research scientist in areas of climate change and ice age history.
And then there are exceptional opportunities for research here. The U of A is a traditionally very, very strong northern school, so that was a big reason to want to come back. And they've invested a lot of money and resources in equipping the labs here in the department for the kind of research I want to do. I'm really mostly interested in things like hundreds of thousands of years worth of climate change.
Reyes most recently spent time on the south of Greenland's ice sheet.
So the capital city is Nuuk, which is right here. And so this is a piece of 3.6 billion year old rock. So this is an igneous rock, a metamorphic rock. We had to go to Greenland and we had to collect samples from all over South Greenland. And then we can use that geochemical knowledge along with the knowledge of what the bedrock underneath Greenland is like to get a sense of when sediments were not shed off of the continent.
You're just separating sediment from water.
That's right, yeah. So we're just using this column of water to separate out different sizes of sediment. It's certainly based on the kind of work that comes out of looking at gas concentrations in ice cores and trying to figure out using fossil plants the concentration of things like carbon dioxide in the atmosphere. We can really say that right now we're really starting to push the Earth system pretty hard in terms of greenhouse gases.
Indeed, the professor spent parts of several years taking samples from Greenland rivers and eroded rocks.
So we want to make sure that sometimes that our sediments that we're looking at aren't contaminated by exotic sand grains or volcanic ash shards.
What's he finding?
We can say that the warming might be very comparable to what we've seen in the past, and so we use the past as an analog to get a sense of what the future might hold. Having said that, we really don't know what the future holds.
Next stop, Yukon.
So we'll be doing some work around Kluane Lake here, looking at these glaciers, and then moving up to the Klondike region of Dawson City to look at ice age environments and geology.
All to help address what might be expected from glaciers and permafrost in future warming.
I suspect what will happen is we're going to end up with periods of time where we have way too much water and then periods of time where we have nowhere near enough water. And I think trying to come up with political solutions and perhaps technological solutions to that uncertainty is going to be really important coming up.
Come September, Alberto Reyes will take it to the classroom. For Go Edmonton, I'm Tim Dancy.